So here we're going to be talking about our last set of quadrilaterals called the trapezoids. They have exactly one set of parallel sides. They are called the bases. That's one base, that's the second base. These are called the legs. There's nothing really distinguished about them right now, but when we get to an isosceles trapezoid, we see that those legs are actually congruent. Just like in an isosceles triangle where we have our two legs congruent across from our base, we have these two base angles that are congruent. That relationship really doesn't change. Actually, looking at this is really just that triangle being cut off at the top with a line that's parallel to the base, forming a second base there. We still have our base angles down here congruent, and really these two and these two are consecutive interior or same side interior angles, so they have to be supplementary. If these two are congruent and these are both supplementary to those two, they have to be congruent to each other also. So really we have our two pairs of base angles. This is one base, those base angles are congruent. This is the second base, those base angles are congruent. So we have two pairs of base angles that are congruent. We also have congruent diagonals, which really we can see from these two triangles that are formed. I'm going to get rid of these and really just think of these base angles squeezed in between this leg and the base, that side, this angle, and this side, corresponding with this leg, this angle, and this side. Those are all congruent. This side matches up with this angle matches up with this angle, and this side is used twice in those two triangles that I'm forming using these two diagonals. This diagonal is part of that triangle, and this diagonal is a part of this triangle. And since I have side, angle, side that are in common between them, I have two congruent triangles, so these parts, this diagonal and this diagonal, are congruent to each other. So we have two diagonals that are congruent. So in addition to these two triangles that I just drew that are actually congruent to each other, the four triangles that we see immediately from drawing those diagonals actually have something special about them. These two are going to be scalene, but they are going to be congruent to each other. And these two, this one and this one, are isosceles triangles, and they are similar to each other. You can see that from this angle and this angle, we have alternate interior angles using these as our parallel lines, and that as the transversal. So those are congruent actually by the exact same logic. Those two are congruent, and we have vertical angles if we want them. So we have three congruent angles. Those have to be two similar triangles also. So we have a lot of properties that we can establish once we have those two legs congruent. Not so much just based on this, but we do have at least the one pair of parallel sides.